Okay, so you refresh yourself using that delta math example. Cool. Now we're going to discuss some things that maybe were a bit unclear or that you have not seen in quite some time. Namely, the different type of functions and what the heck is Boolean and what does it have to do with the restricted domain. Let's see. F of x terminology, you may have thought, oh, I know this too. That's okay, we're going to go over in 30 seconds or less. It's not strictly true that f of x is the same thing as y. We use it as a shortcut when we're first introducing it, but you're in a higher level math class now, so we're going a bit more into it. It doesn't replace y in terms of ordered points, but you can graph out where you just say, well, my y value is just the result of a function. It'll do the exact same thing that you've done in the past, but I just need you to know that y is not exactly equal to f of x. So, names of functions, the stuff that you may have looked at and gone, this is a lot. You've seen a ton of polynomial stuff before. Polynomials will have graphs that look like roller coasters. Quadratics have U-shaped graphs. Linear is just straight line. You've seen those most. Exponential, start off and then sweep up like that. Rational, maybe you haven't seen too much, but we will go more into them. Rational kind of dive off like that. They have somewhat strange looking graphs. Now, the ones that you may not have seen before, for whatever reason, are these. So, power functions are just special cases of polynomial functions. Instead of having a bunch of polynomials, you just have a monomial. Direct variation are special cases of linear power and polynomial functions. And all it means is as the x goes up, the y goes up accordingly. Inverse variation is a special case of the power function where the opposite happens. As x goes up, y goes down. So let's focus on direct variation first. Direct variation would look like this. It looks very linear. And that's just because as the x is increasing here, the y is also increasing. Now, inverse variation, as you've read, a lot different. It looks like this. That's because as x is increasing, y has to decrease accordingly. They're going in opposite directions. What is arguably the more annoying part of this section, and what seems the most confusing, are restricted domains, otherwise known as Boolean variables. You hear a lot about Boole. He was a famous mathematician and computer scientist when you're talking about, well, computer science. That's because Boole deals with zeros and ones and was instrumental in starting the idea that computers use binary, of 1 meaning true, 0 meaning false. Restricted domains seem annoying, and you may have read that section saying, I have no idea what's going on. They're a good concept. We know that not every graph describes something perfectly. Real-world stuff gets in the way. So maybe you're like, hey, this function really describes the habits of rabbits and their activity levels as determined by temperature. Rabbits will hibernate. But you don't need that function to go into 200 degrees. No place on the surface of Earth is 200 degrees. You also don't need it to go to absolute zero. No place on the surface of Earth is zero. And you're not going to find rabbits in space. Think about these like conditions. If the conditions aren't met, the function doesn't graph. And here's an example. So to park in a certain parking lot, it costs a base fee of $5 plus $10 an hour. Explain why a restricted domain is a good idea here. And a graph can help. If I graph it out, my base fee of $5 is going to be like right about here. And the $10 an hour is going to be my slope. So it's going to go up like this. We know functions go on forever in both directions. Down like this. This is our time. And this is our cost. Well, we don't need anything on this side. That's because time would be negative. And for our purposes, time is never going to be negative. Heck, in any of the college math courses I took, time was never negative. So here we could say that the restricted domain has to be x is greater than 0. I said greater than 0 because if it's equal to 0, you're still not paying anything. If you've spent literally 0 seconds in this parking lot, you're not going to pay anything for the parking lot. Now, it's also a good idea if there was some upper bound here. If the parking lot said any car after 48 hours will be towed, then you could also say that x has to be less than 48. And then you could easily write this by saying 0 is less than x, which is less than 48. And this would be your restricted domain in the curly Q brackets. I'll show you how to graph this out in Desmos. So here we are on Desmos. You can just do this. You can also look in our materials section. And I want to use that same example we just looked at. F of x is equal to 5 plus 10x. You can see that it's a linear function, as we'd expect. It goes on forever in both directions. If I wanted to change or restrict the domain, I'd put a little curly Q bracket. 0 is less than x. And all of a sudden, Desmos is not graphing anything out where 0 is greater than x. All the negatives are not being graphed. It ends at this point. Now if I say less than 48, then close my curly Q, it'll do the exact same thing. However, this is a very steep function, so you might not see it. If I zoom out a bunch, though, you can see that the graph stops. Here, every gap is about 50. This stops right before the gap ends. So it's a good way of restricting the domain. Now, suppose you wanted to put into Desmos that this was less than or equal to. Well, after you type in this symbol, you would just hit Enter, and it would change the symbol to less than or equal to. Hit Delete, and it goes backwards and undoes it. So at this point, you might be thinking, okay, that was a lot of information. I need to work with it. And that's great. You're going to have some time to work with it right now. Your next assignment is numbers 1 through 39 odd, which means you're doing 1, 3, 5, 7, 9, 11, so on and so forth. You're not doing the even ones. And you're also doing 40. 40 is a writing task, and it's a good thing to do. Writing is always a wonderful thing, even in a math class, and you will do a lot of it in this math class. If you have any questions, head on back to Live Gallagher. He will definitely help you out. Digital Gallagher, signing off.